Welcome to AP Physics 1 with Mr. Brazil. I will be discussing linearization, part 2. We're going to be looking at a little more complicated equation just to whet your taste and increase your strength in linearization and what that means. Here we go. So let's say you have a pendulum, and a pendulum swings from one side to the other and back. That's called a period, and it's timed in seconds. It's due to gravity. Well, can we determine the gravitational acceleration of that pendulum? Well, if you were to change the length and plot the time periods using a photogate to collect the data, you would get a graph that looks like this, which is a polynomial. And you could find gravitational acceleration using polynomial regression, but it's easier to linearize. So let's give this a shot. The equation for a period is 2 pi L over G. And by doing a little algebra, we can determine G. And if we were to factor out root G, so in other words, 2 pi over root G times root L, that forms in a y equals mx plus b type equation, where m is the slope of the line, 2 pi root g, and x, the independent, is root L. If we were to plot root L instead of L versus the period, we can produce a linear equation. Now, we cannot change y. Y remains the same. Regardless, 0.5 square root will still provide 1.22, while 0.5 is 0.71, okay, square rooted. So you're going to get a linear equation with a slope. The beauty is that this slope is 2.062 seconds over root m meters, which is equal to the 2 pi root g. If we do some more algebra, we can rearrange this, and voila, we can now determine the gravitational acceleration for a particular experiment. In this case, 9.29 meters per second squared. This could be an experiment that you've designed, you collected the data, or you could be an astronaut on another planet and you're using a photogate and you're trying to determine the gravitational acceleration for that planet. The beauty of linearization is that it can be applied to almost any equation that allows to the y equals mx plus b format. Example, determining force between two objects. Instead of plotting r, plot 1 over r squared versus the force. The slope will be g times m1 times m2. Well, the masses of the two objects won't change, but you can now determine g with a little algebra, much like what we did for little g. Or let's say you have a variable resistor and you put it on a setting and you want to know what that resistance is. Well, you could have an oscilloscope giving you the current and the power. If you were to plot I squared versus, power versus I squared, the slope of that line will be the resistance, which is cool. Now you could change the resistor, collect a bunch of data, and a variable resistor, and you can end up finding the exact or close to near exact resistance. So this is a beautiful tool. It's a math tool that you need in your math kit for physics. So enjoy, and if you have any questions, look and check out other teachers who've done videos on linearization. Keep it up. Bye.